All right, this is the divide and slide method. Okay, we're in the same place on the factor chart that we were a while ago. We've already checked for a GCF. We determined it has 3 terms. It is not a perfect square trinomial. Its leading coefficient is not 1, so that means we're going to have to do what he calls the long way. I call it the AC method, but this is the divide and the slide. Okay, so the problem says we've already factored out GCF. Multiply A times C, looky there. 12 times 2, AC is 12 times -2. That's going to give me a -24. And it says rewrite the trinomial. So we rewrite this. We're going to pretend for just a second that the 12 has been moved back here. So we rewrite it so that it has a leading coefficient of 1. We rewrite it so that it is one of these easy kinds. Okay, but so we take the 12 off, but we put this as -24 right here. So that's why we call this the AC method. We multiply to A times C, and now we're just going to pretend for a second that this has a leading coefficient of 1. The 5 stays where it is. So we're going to pretend, now we just pretend that A is equal to 1. And so if A is equal to 1, then we're going to find factors of -24, and we're going to find a sum of 5. Okay, so factors of -24. So 12 times -2. That's a way to get -24. 12 times -2, but 12 plus -2 gives me 10. That's not what I need. I'm gonna try, what's next? What about 6 times -4? 6 times 4 will give me -24, but 6 plus a -4 gives me a 2. I need a 5. Okay, so let's try 8 times -3. 8 times -3 will give me -24, but 8 plus a -3 will give me 5. That's the one that I wanted. So since I'm pretending that A is 1, when A is 1, these are my factors. This becomes x plus 8, and this becomes x minus 3. But remember, these are the factors of this one. And this one was obtained by multiplying times 12. So what I have to do now is I have to divide. Since I have multiplied by 12, I now have to divide both of these by 12 to undo what I did. Okay, so let's see. Multiply the AC method. The third term is a product of AC. I don't know. I put my slide somewhere else. I'll show you where I do my slide in a minute. Factor using strategies when leading coefficient is 1. So the factor sum method. That's what I'm doing right here. This is step number 3 right here. Divide each numerical term by the original leading coefficient. So I'm dividing by 12. This is the divide part. He said slide that 24 in. I say divide goes here, and I'll show you where the slide goes in just a second, where I say the slide goes. 8 divided by 12. We need to reduce that out, divide out any common factors. So 8 over 12 becomes 4 times 2, and that becomes 4 times 3, so the 4's divide out. And then this one right here also is 3 times 1 over 3 times 4. So the 3's divide out. So this is x plus 2/3. And this is x minus 1/4. Now here's where I do the slide. I slide that denominator in front of the x, and I slide that denominator in front of the x, and that's the final answer. Okay, so I did the AC method, and then I pretended for just a second that A was equal to 1. I factored that problem. Then I had to, since this was the factors of the 24, I had to divide out the 12. So there's the divide, and then here's my slide. And these are almost always going to be fractions, and if they're not, it's okay. It doesn't have to be a fraction, but if they are a fraction, you slide that denominator over in front and you slide that denominator over in front. There's really a mathematical explanation for that, but I know y'all are so overwhelmed right now with all the math. I will talk about it at another time. If you're ready, you can say, hey, send me an email, say, hey, I'd like to understand the mathematical terminology here. We're actually going to discuss it much deeper when we start solving these and setting them equal to 0, but right now, that's why I call it divide and slide, because I do the division right here. That's where I get my fractions, and then I slide my denominator over. All right, that's the divide and slide.